Hello friends, good evening. My name is Jaswinder. Welcome back to my YouTube channel. Today we are going to start syllabus of Standard 9th, Class 9th, NCERT, Chapter number 1, Number System. In this, first of all, we will discuss about basic number system that you studied in previous classes. First of all, natural number. Natural number we are using for counting. Natural numbers are starting from 1, 2, 3, 4, 5, 6, so on. All positive numbers are here. And then whole numbers are starting from 0, 1, 2, 3, 4, 5, so on. Then integer is a collection of negative number and whole number. So for this we will make a diagram. In this diagram, first of all, we will make a square box. This square box is representing natural number. Natural numbers are represented by n. N is equal to 1, 2, 3, 4, so on. Then whole numbers are represented by W. Okay. Then integers are represented by Z. Okay. So beta, first of all, I made a natural number in a square box, and further we'll make one outer square. It is representing whole number. Okay, because natural numbers are contained into whole numbers, because all natural numbers are there in whole numbers. Clear? So next, after whole numbers, we'll make one more square, big square. In this we will use Z. Z means integer. Why integer? Because in integer you know that when we are writing integer 0, 1, 2, 3, 4, 5 on right side and on left side negative number. So it means this whole numbers integers containing natural numbers also, whole numbers also, and negative numbers. So that's why this big square is containing these both small squares. Okay, clear my dear? Next, now we will going to start that in between these integers which kind of numbers are exist there. If you might have seen number line, on number line while we are representing integers, then in between these number we have not represented any values. Okay, so now, but in between 0 and 1 few values also exist here. How? Because we know if there is a full part of a circle, you can divide it into two parts. Now half here, half here. Earlier it was full, it was one piece. Now we divided it into two parts, so it is half and half. So it means in between 0 and 1 there is a value just half. That how we are representing it? 1 by 2. Okay, if you can take more value, you divide this 0 to 1 into 3 parts, then what you will get? 0 to 1 you will divide into 3 parts. So this will be represented by 1 by 3, this will be represented by 2 by 3, because this total piece will be divided into 1 by 3, 1 by 3, 1 by 3 parts. So it means in between integers there are rational numbers. Okay, rational numbers are of which form? Rational numbers are of the form P by Q. Which numbers we indicate in the form of P by Q, that are rational numbers, where P is integer, P is also integer, and Q is also integer. This you keep in your mind, that whenever integer upon integer there, that type of numbers are known as rational numbers. Okay, so it means these rational numbers are in the form of numerator and denominator. Okay, but there is one condition, that this Q never should be 0. if q will be 0, then this value will be undefined. If q will be 0, if q is equal to 0, then this p upon 0 will be undefined. So you keep this in your mind that q will not be 0 in case of rational numbers. Okay beta. Now this big square, after this integer we will draw one more square. This large square is represented by q. Q is used for rational numbers. Q is used for rational numbers. Rational numbers. Okay, it means rational numbers contain all the integer, all the whole number, all the natural numbers. Okay, so now there is one question that all integers are rational numbers. How? Look here. If you want to convert integer into rational number, what you have to do, I am making here a series -3, -2, -1, 0, 1, 2, 3, 4, so on. If you will put 1 upon them, like 0 upon 1, 1 upon 1, 2 upon 1, 3 upon 1, 4 upon 1, -1 upon 1, -2 upon 1, -3 upon 1, there is no any change in their values. Okay, this 1 will remain the same, 2 will also remain the same, 3 will also remain the same, 4 will also remain the same. But now they are of which form? I told you that you have to keep in your mind these numbers are now in the form of integers upon integer. 0 upon 1, 0 also integer, 1 also integer, 1 also integer, 1 also integer. Now it means these all integers we can express in the form of rational numbers. So what it means? It means all integers are rational numbers. All integers are rational numbers. Why? Because we can express them in the form of p by q. This is our basic definition of a rational number. Which number you can express in p by q form? They are known as rational numbers. Okay. Now this is your example in your math book. Now if they will ask from you that opposite of this, that all rational numbers are integers, no. Why no? I will show you one example here. If you look in your book, they are asking in example number 1, part number 3, that all rational numbers are, all rational number means q, all rational numbers are integer, q means rational number, z means integer. So for this we will take one example. You take example of 2 by 3. 2 by 3. Now you look there. 2 by 3 we can simplify it further. No, it will be in the form of 2 by 3 only. Now 2 by 3 is coming in between integers. You look here in this chain, that 2 by 3 is there in this series. 2 by 3 is not there. It means what we can say, that this third statement is false statement. All rational numbers are not integers. All rational numbers are not integers. Okay beta. All natural numbers, all rational numbers are not integers. Now once again we will check all parts of example 1 from your NCERT. First one is there, whole number. Whole number we are representing by W, that all whole numbers are natural number. Okay, but I am writing in short form. W means whole number, N means natural number. So we'll check that all whole numbers are natural number. No. Why? Because whole numbers are starting from 0, 1, 2, 3, 4, 5, so on, and natural number starting from 1, 1, 2, 3, 4, 5, 6, so on. It means all whole numbers are not natural numbers. Why? Because 0 is not there in 1. So what is this? This statement is false. All whole numbers are not natural numbers. Why? Because 0 is not there. So if you will do opposite of it, that all natural numbers are whole number, that it is true. Why? Because all natural numbers are there in these whole numbers. Clear beta? From 1 to 3 4 these all are there, they are contained in whole numbers. So if you are going a reverse direction, natural to whole, then it is true. TRUE, true. But if you are going from whole to natural, then it is false. Clear? So then we did the second part. In second part, what we discussed? We discussed that all integers are rational numbers. How you can express this? Downside of an integer, you just put 1 and these all integers will change into rational numbers. Clear, my dear? Because they are in the form of p by q, numerator upon denominator. It means integers upon integer. Clear? So next, third part. In third part, I explained you that rational numbers are integer. No, it's a false. Why? Because this kind of rational numbers are not present in integers. I hope up to here I am clear to you people. Now we will proceed further. Now in exercise 1.1 there is a question that 0 is a rational number or not. But while we were discussing that integers are rational number, there we have taken 0 also. 0 we can express 0 upon 1. If 0 upon 1 there, it means it is in p by q form. If it will be in p by q form, that means it is a rational number. So what we can say, that question number 1, what is its solution? That 0 we can write 0 upon 1. It means this is in p by q form. If it will be in p by q form, that means it is a rational number. It is a rational number. Okay, beta. So now after this we are going to start very interesting topic, that we will find out rational number between any two given numbers. Okay, rational numbers between any two given numbers. Like when we started here, I told you that in between two integers there are number of rational numbers. That how we can find out them. Okay, how we can find out them? So here is a question, how we can find rational number between two integers or rational number. Integer or rational number, I told you that same thing, we can convert them into rational. How? Suppose in exercise 1.1 there is question number 2, they have given you find out 5 rational number between 3 and 4. So first of all you convert them into rational numbers. How? You can write them 3 by 1 and 4 by 1. Okay, further you can write them 3 upon 1. How you can write? You can write 9 upon 3, because when you will cancel out them, it will be also 3 upon 1 only. And this side also, how you can write 4 you can write 12 upon 3. Okay, when these both will be same to same, okay, make their then you can check there. Here is 9 by 3, here is 12 by 3. These are two numbers which are only form of this 3 and 4. 3, how we can write 9 upon 3? When you will cancel them, it will give you 3 only. When you will cancel out them, this will give you 4 only. So now this is the first step, to change them into two fractions with the same denominator. Okay, my dear. Suppose on the place of this, okay, you can take 6 upon 2 and you can take 12 upon 3. Means you have taken two different values for 3, because when you will cut them, this will also change into 3. If you will cut them, this will also change into 4. Suppose you have taken a number with a different denominator. So what is your first step? First step, we have to make the denominator same. How you can make the denominator same? By cross multiply. Okay, 6 upon 2, this side also you will multiply with the 3, and this side also you will multiply with the 2. Okay, how? Because this side fraction you can multiply with the 3 only. This side fraction you will multiply with the denominator of first. I am repeating again, understand this step, that first fraction we will multiply with the denominator of second, and second fraction we will multiply with the denominator of first. Now its value will be 18 upon 6 and its value will be 24 upon 6. Okay, so now these both parts, you look there, two different approach I have applied, first and second. Okay, in this both we have taken a different solution for these two numbers 3 and 4. Okay, so now they are with the same denominator. So to find out how many rational number we want to find out, we want to find out 5 rational number. So what you will do, you will multiply these both fraction with the 6, upper side also, down side also. 9 by 3 multiply with 6. This is the second step. And this side also 12 upon 3 multiply with 6. This side also with 6. It will be 54 upon 18, and this will be 72 upon 18. So now when you will start writing, it's a series that 54 upon 18 to 72 upon 18. So now you know that denominators are same only numerator is different. Numerator's value you increase 55 upon 18, 56 upon 18, 57 upon 18, 58 upon 18. This value you can write up to 72. Okay, but how many number you need? You need 5. You pick any 5 from here and you can write it as its answer. How you can write? So the fraction between 3 and 4, from this you can write, because beta in this 5 by 18, 54 by 18 means 3 only, because when you will cancel it with the table of 18, it will become 3 only. And this side 72 upon 18, when you will cancel them, this will also will be 4. So in between this, which numbers are there, I am writing in this box: 55 upon 18, 56 upon 18, 57 upon 18, 58 upon 18, 59 upon 18. You can choose up to 71, any 5 number. Okay, but numerator you increase, denominator will remains same to same. Same for this part. This also same approach. 18 by 6 came, 24 by 6 came. Now 18 upon 6 and 24 upon 6, in between you can find out a number. 18 upon 6, then 19 upon 6, 20 upon 6, 21 upon 6, 22 upon 6, 23 upon 6, 24 upon 6. Now in between these two numbers, there are how many numbers? 5 numbers. So this is also a solution. So two approaches I told you, same method in both. In one we have taken a number in a same with the same denominator. In one we have taken a number with a different denominator. And this method you can use to solve question number 3 also. So our first question over, second over, third over. Now fourth question of exercise 1.1. Fourth question. Question number 4. So in question number 4, what is the question there? There are true and false. You have to state that every natural number is a whole number. This I already told you in our previous solution, that every natural number is a whole number or not. This is a converse of here. You look here, pause the video and you look again. I explained this. All natural numbers are contained in a whole number. That's why this answer is true. Clear? So second, every integer is a whole number. Every integer is a whole number. So beta, my dear, first part I already explained. Second, in this every integer is a whole number. Beta, in integer there are negative numbers also. 1, -1, -2, +1, +2 and 0. So these negative are coming in whole numbers. Whole numbers are starting from 0, 1, 2, 3. So negative numbers are not there. Negative numbers are not there in this. If it is not there, so that means all integers are not whole numbers. So this statement is false. Okay, now it's last part, third part of our exercise. Every rational number is a whole number. Rational number is a whole number with W, rational number with a Q. Okay, so in rational number what are there? 1 upon 1, 1 upon 2, 1 upon 3, so on. So this 1 upon 1 means 1. Okay, so it means 1 is there in whole number, but this 1 by 2 is there in whole number, not there. It means this statement is also false. So in this video we discussed exercise 1.1. Thanks for watching my video. Keep in touch, subscribe and share with your friends. I hope you will be safe at home. Okay, thank you for watching.